So this is example number 2. And so here we're going to factor out a 4. It's the largest number I can take out of both of these. I can also see I can take out an x squared. So 4 times 2 is 8. I need 3 x's, so I attach one more. 4 times 1. Now, the mistake a lot of students make is they just write it like this. You need to put a sign in front of the 1. I want it to be positive. And I need 2 x's. I already have it. I'm going to copy and paste what I had and put it in back. And then I'm looking for that magical number. So what times 2x gives you a positive 2x? You can't just put a 1 down. It has to have a sign in front of it. So it's going to be a plus 1. Multiply, that works. Multiply, that works. So what do? Think of this as a front half and a back half. They both contain a 2x plus 1. In front of the first part is 4x squared. In front of the second part is a plus 1. A lot of students see this and they're like, oh, here's the x squared. And here's 4 and 1. They're both in that list of perfect squares. So I go 2, 2, x, x, 1, 1. But why can't I do that with this part? Because it's a plus sign. It's a plus sign. With binomial expressions, you can't. So we'd be completely done at this part. Okay? Let's move on here and do a more complicated problem. And then we're going to do a fourth one where we need to factor something numerical value out. So here we go. So this one has 2 different variables involved. Okay, so here we go. You ready? When I look at these first 2, I have a 3 and a hidden 1 up front. And I'm like, 3 and a 1, what can I do? Well, I can't take anything other than a 1 out. 1's not going to help me. I can take out x's. I can take out a maximum of how many? 2. Okay, so I need a 3x cubed. That's what I need. So I need to attach a 3 and an x. I got to make sure I did it right. Okay, yep, that gives me 3x cubed. Then I need a 1, and I already have the x squared, and a y. Whatever I have in parentheses goes in back. 3x plus 1y. And then I'm going to put that little question mark here. Is there something I can take times 3x and end up with a negative 3xy? Is there something I can take times 3x and end up with a negative 3xy? And the answer would be a negative y, or a negative 1y. When I multiply these, I get negative 3xy. When I multiply this, I get negative y squared. So think of this as a front and a back. They both contain 3x plus 1y in front of the first and in front of the second. And now the question is like, how do I know if I can go further? Well, first of all, we got to look just to find the part that has an x squared, or a value here that can be broken apart. So in this one, I have a y squared. Okay, that's great. And there's a 1 in front. Okay, that could break down into 1 and 1. This could break down into x and x. I have a subtraction sign. Everything's looking good. But when I look at the value of the exponent on the y, 1 cannot be broken into y and y because it only has one y. If it was a 2 or a 4 or a 6, an even number, we could break it apart. Since we can't break apart 1 into 2 values that would both be whole numbers, I'm completely done. And here's the last problem I'd like you to write down. 4x cubed minus 6x squared plus 4x minus 6. Just a different variation of what we're going over. A slightly different look. Now, what's different about this? When you look at all those numbers, they're all what type of numbers? Even. So what can you always divide out of even? When it's possible, and you can divide a number out of every single one of the 4 terms, you need to do that first. So 2x cubed minus 3x squared plus 2x minus 3. And then I'm going to kind of forget about this until the very end. I'm going to focus on this. So out of these first 2, I can take out an x squared, and I'm going to go through this a little bit quicker. 2x minus 3. I got to make sure I did it right. Then I'm going to copy and paste this in back and ask myself, is there something I can take times 2x and get a positive 2x? Yep, that'd be a positive 1. Okay, that works. And that works. So what do I do now? Well, they both contain that 2x minus 3. In front of the first is x squared. In front of the back is plus 1. And don't forget about the 2 out front. But we still have to ask ourselves, can we completely factor this? So if there's the x squared, we're going to focus. I have an x squared, that's great. I have a 1 and 1. Remember, this breaks down and this breaks down. All of this is good. But what holds me back from going further? Anybody? It's not subtraction, so this would be completely factored.